This is Arduino Lab number 3, objective 1A, using the 4-pin LED to change different colors using the RGB system. This is the basic setup, the same as last time, or same as always. Going from power to ground, from the numbered pins. Red going to pin 9, green going to pin 10, and 11 being the blue pin. These 3 pins then go to the breadboard through their respective pins on the LED after passing through resistors to keep the LED from overpowering, then back to the ground bus to complete the circuit. And I'll go ahead and reset the system here to show you the color sequence is right. Red for 2 seconds, green for 2 seconds, blue for 2 seconds, purple, cyan, and finally yellow. Here we have the code for objective 1A, starting out with just good coding technique, name, what the project is, and what the class is for, or company, if you were doing professional work. Then we define these 3 constants as integers for the red pin, green pin, and blue pin. The reason we're doing this is to give us some context when we look down here. Instead of just seeing pin numbers, we're actually seeing what the pins are going to for the LEDs. We then initially, in the void setup, set these pins up to all be outputs. Then going to the loop, we're simply just running through the colors, using the different digital writes to turn each pin on and off when we want it to, starting with just turning red on, delaying for a time delay, which I set up at the top as an integer of 2000, so that if I was ever to change it in the future, I would just have to change the integer at the top of the code rather than each time delay individually for each section, just to save time in the future. And next we turn on green, each one for 2 seconds, then blue, and then red and blue to make purple, green and blue to make cyan, and then last but not least, red and green to make yellow. This is objective part 1B. The pin setup is the exact same as it is in 1A, so I'm not going to go over that. If I reset the system, you'll see that the colors go in the correct order. Red being first, then going to purple, then going to white, then to yellow, then to cyan, green, and lastly off, all for 2 seconds each. Okay, so this is the code for objective 1B, very similar to the code for objective 1A, with a few changes in the pin output setup down here and the order they go in. It starts out the same basic way with all the info up here, the time delay, and instead of going in the order it was before, it now goes red, then purple using the red and blue pins, white using all 3 of the colors mixed together, yellow using just red and green together, and then green, blue to make cyan, green alone, and then we turn all of them off to finish. This is objective 2A from lab 3. All of the LEDs are wired into individual pins running from pin 2 to pin 11 through the LEDs through 330 ohm resistors back to ground bus, all traveling through the ground wire back to the ground pin. If I press the reset button, the code is set up to turn each one on individually in ascending order and leaving them on indefinitely. Here we're looking at the code for objective 2A. Same thing, start out with the name, project, and company/class. We begin with a void setup. We use a for loop this time to set up each of the pins going from 2 to 11, or less than 12 in this case, was what I typed in. Adding each time going through, so what this does is it goes through, sets pin 2 to an output, goes back, adds 1, sets pin 3 to an output, goes back, adds another one, sets pin 4, so on and so forth, etc., etc. What this does is allows us to enter 3 lines of code rather than 12 lines of code? Yeah, 12 lines of code. That sounds much worse than 3. This just makes it more efficient, and it does the exact same thing, which is why for loops are so useful in this respect. Then we go down to the loop function after we set up each pin to be an output, and we use another for loop to run through one time, turning each pin on, one pin on at a time in ascending order each time it goes through. Turning one pin on, waiting 0.2 of a second, going back, changing the integer to the next pin, and then turning that pin on, etc., until you reach the 11th pin, and then they remain on indefinitely.
This is Lab 3, Objective 2B. The first part of the code is the exact same as it was for 2A, turning each LED on individually in ascending order. The only thing different is there's a second for loop added into the code line, which turns them off in ascending order, and then this repeats.
This is the code for Objective 2B. This is basically exactly the same thing as the code was for 2A, using the same for loop at the top for void setup to set up the pins as outputs. Then we go into void loop, where it's the exact same for the first block of code, turning each LED on, going through that for loop, then kicking out of that for loop once all of the pins are on, which means that the pin number is greater than 11, and kicking into the next for loop, which is the exact same setup as the previous for loop, except this time we're turning each one off in ascending order. So what this does is it turns each LED on in ascending order, and then it'll go back to the beginning and turn each one off in the same direction that it turned them on.
This is Objective 2C. Wiring is exactly the same as it was for 2A and 2B, and the for loop is similar, except now we are turning the LED on and off within the same loop before moving on to the next LED in the line. This is doing this in ascending order, turning them on and off in the same loop, and going on indefinitely.
Now we're looking at the code for Objective 2C. It begins as the same as it was for 2A when we set up the pins, just using that exact same for loop to set them all up as outputs, so that each pin is receiving 5 volts when we tell it high and nothing when we tell it low. The loop is, instead of using 2 different for loops, one to turn them on, one to turn them off, we've now used one for loop to turn them on and off individually for each LED before moving on to the next LED. So what this does is it sets the first LED, pin 2, to on, waits 0.2 of a second, turns it back off, waits 0.2 of a second, and then goes back and changes to the next pin up, so on and so forth, until we get to pin number 11. And then it will go back to pin number 2, setting it there, and continue this for loop indefinitely.
This is Objective 2D. This was the objective for the tutorial video, which is similar to the Knight Rider. I went ahead and kept my setup as I was before with the 10 LEDs rather than the 7 that they had set up in the video. The code is the same, I just changed the for loop to add 4 more iterations to get all the LEDs in the mix instead of just the 7. It's turning each LED on individually before moving on to the next one, and then going back in descending order and ascending order, which causes the light to go back and forth.
Now this final objective, Objective 2D, uses the exact same for loop as we have for the other Objective 2 sections, except I just changed the name from what it was previously to LED pin to kind of match what they were doing in the tutorial video, but it's serving the exact same purpose. The only thing it's doing is turning each pin to an output. Then we go down to the loop section, where we are essentially doing what we were doing before with 2C, except we're doing it twice and in reverse order. So what this does is it goes and turns on each LED individually from high, and then waiting for the timer time, which is an integer set at the top of 1/10 of a second or 100 milliseconds, then turning it off, going to the next LED or pin number and doing the same thing in ascending order until we reach 2 to the 11th pin. Once it reaches the 11th pin, it kicks out of this for loop and goes down to the next for loop, starting with the 11th pin and doing the exact same thing it was up here, turning each LED on and then back off again before moving on to the next one, in descending order from 11 down to the second LED pin. And it'll do this indefinitely, which bounces the LED back and forth on the strip.